Excellent. So yeah, very warm welcome. Thank you for giving up your time on this lovely spring afternoon. Yeah, we're delighted to welcome you to this session talking about water quality in the River Culm as part of the Connecting the Culm project. If you don't mind, I'll just share my screen. I've got a few slides. Just press the button. Hoping you can see that okay. Could Sarah just say yes if you can? Can you see it yet?
Yeah, we can see it.
Excellent. Yeah, so the first thing to say is a few introductions. So I'm Tim Youngs. I'm the Blackdown Hills Area of Outstanding Natural Beauty Manager, and I'm also Project Director for Connecting the Culm. Yeah, joined this evening by a number of colleagues, Dominic Ackland, Catherine Caulfield, Sarah Ward, Anna Seal, and a few others. So hopefully you'll see their faces on the screen. We've got a few apologies this evening. One of them is from the Environment Agency, and I'll talk about that in just a minute. So just a bit of the usual housekeeping, if that's okay. So stay on mute unless you're invited to speak. We're very keen that you put your comments in the chat, please, as we go along. And then various members will answer any immediate questions, but the main reason is to store them up at the end, and then we can have a question and answer session. And obviously it's being recorded, so we've got a note of them as well. And the plan is we've got very excited that we've got 5 live speakers with us this evening, late afternoon, and we've got a video presentation. So we're going to take all the speakers in the video presentation and then have a question and answer session at the end, followed by a sum up as well. So we'll use all the chat at the end to form the question and answer session. So let's just move on. So that's all the housekeeping. Hoping you can read that. So the programme, I'm going to give a quick introduction. Then we've got Professor Peter Hammond from Windrush Against Sewage Pollution, or WASP for short. Then we've got a video from Dr. Holly Pearson, who can't be with us in person, but she's made a presentation. Richard Horrocks, Riverfly Coordinator. Then we've got Ross Cherrington, Westcountry Rivers Trust Senior Farm Advisor. Really pleased to have Mark Worsfold here as well, Southwest Water, and then into the question and answer session. So it's my job to make sure we stay on time, and we'll be done by 6. And sorry, this is a little bit formal, but if you're happy to just quickly read that or skim it, the Environment Agency couldn't be here this evening, but they sent this statement, which we can share with you afterwards. So I'm not proposing to read it out. Hopefully you can skim it and and get the gist of what it's about. And as you can see, there's links there that we'll perhaps we could put in the chat a bit later, or certainly we can send it to you afterwards. So I wasn't going to labour that point. It was just to share that with you. So I'll move on now, hoping that you've had a chance to read it. Okay. So yeah, into the introduction to the Connecting the Culm then. So it's a catchment-based project. It covers the Culm catchment, which starts up in the Blackdown Hills AONB in the sort of lightly shaded right-hand side of this map. And then it flows all the way down through Culmpton, eventually ending up just on the edge of Exeter. So it's a 300 square kilometre-ish catchment. And these are the main partners here who are involved. So it's ourselves in the AONB, Devon County Council Environment Agency, Mid Devon, National Trust, Westcountry Rivers Trust, Devon Wildlife Trust, amongst others. So it's primarily funded by, or at least this stage of the project, primarily funded by Interreg 2Cs. It's part of a program called Co-Adapt. And don't worry about all the text. It's just to give her the essence of the project, which is that it's got 3 parts of the jigsaw to it. So it's about co-creation. So it's about coming up with solutions that empower communities and are jointly worked up together and with landowners. And it's about strategic planning. So it's linking to the Culm Garden Village and other property flood resilience and other measures, sustainable drainage systems. And then on the left, bottom left, nature-based solutions. So it's really looking for different ways of doing things into the future. So how can we not just use bricks and mortar to make walls higher to keep floodwater out? How can we work with nature, whether that's tree planting, debris dams, or such solutions? And then climate change adaptation, it's about, well, how can we work with communities along the Culm catchment to help them adapt to the challenges before them? So we're trying to mitigate the impacts of climate change and help communities adapt as well. And our the kind of golden goblet, if you like, at the end of our what we're aiming to achieve really is called the blueprint for the Culm. So it's a 25-year plan, and it sets out what needs to happen in the catchment in order to build resilience against flood, drought, improve water quality, restore biodiversity, store carbon, etc. So it's across multiple objectives, and it's a long-term vision. And we're actually making really good progress towards building this blueprint. And we're certainly keen to hear from anybody who wants to help us on that process. So we'll talk a bit later, if we've got time, about all the different funding elements that we've secured or we're about to secure. So just to rattle through some of the issues affecting the catchment very briefly. So the one we've been looking at to date is flood and drought primarily. So it's about looking at places like Heel Crossing on the railway line, on the West Coast main line, and then looking at flood events like November 2012, which is the photograph on the right-hand side. And we've done a complex hydrological model to show what happens if you put various measures in upstream. What effect will that have on this sort of infrastructure? And we've looked at other aspects as well. So we've looked at soils in quite a lot of detail, and we're doing soil sampling as well. Obviously a key part of land management. Water quality, so we've looked at the Water Framework Directive data, which is a little bit opaque, but you can start to split out failures across the catchment, and the whole catchment is failing. The status is either moderate or poor, nothing is good. So it's a pretty sad picture, but quite typical of other rivers in the southwest and the rest of the country, unfortunately. And we've also done some biodiversity mapping, put that in the mix. And then this slide is particularly interesting because it looks at total phosphorus inputs. So this is based on the best available data we've managed to get, and it shows the split in the various water bodies of phosphorus/phosphates across agriculture, sewage, urban diffuse, septic tanks, etc. So I'm sure this will be coming up later, but this is an overview of the data that we've built into our evidence review. And then this is a collated picture. So the darker the hexagons, the more of a heat map it is for where nature-based solutions could be most effective to tackle the challenges and the issues affecting the catchment. And from that, you might see some little dotted lines. That's how we've chosen priority areas to focus on. And then we've done some work with a local artist to show what the catchment looks like now, which is this picture here. So you've got maize being grown on some quite steep fields. You've got quite high livestock densities, not many trees. You've got rapid runoff of water leading to flooding of properties and roads. And then the map or the diagram map in the bottom right shows the flip side of that, where the opportunities are to build in nature-based solutions into the catchment to really make a difference for all the objectives. And then our co-creation activities focused on 3 main groups. So key authorities like Network Rail, Environment Agency, Mid-Devon District Council. Yeah, landowners have put a lot of time and effort into working with landowners and farmers, and then communities themselves, and obviously all those overlap as well. So yeah, rapidly running through what we're talking about this afternoon / early evening. So as we've said, we've gathered a lot of information on all the objectives across the catchment, including water quality. So we believe that in terms of water quality, that the failure is largely due to agricultural diffuse pollution, but also sources including domestic waste discharges. And on the agricultural diffuse pollution, Ross will talk about this in a minute. But as I said, we've done a lot of work with individual farmers and groups of farmers to support and guide them through agricultural transition. So I explained that we'd done a lot of work on flood and drought, but we are very much focusing on water quality as well, hence why we're facilitating this discussion this evening. But we know there's gaps in the data, so especially localized impacts, which is what we're keen to hear about this evening. There's increased coverage of citizen science water quality monitoring, which will help fill these data gaps. And the other message is really there's opportunities for all of us to make a difference, whether it's what we flush down the toilet or how much water we use. And yeah, getting involved to find out more about the health of the river. So the outcomes we're hoping that will be initiated from this discussion. So we want to better understand what's driving water quality failures. We want to fill knowledge gaps, agree what needs to happen to address the failures at all levels, tackle failures using a triaged approach, monitor and evaluate, and keep interested parties informed. So it's quite ambitious, but it's obviously what's absolutely needed. And we're hoping this evening that we'll have a constructive conversation. We're looking for how best to work together and set out a route forward, if you like, for how to turn over those stones, find the data we need to find, and figure out what we're going to do about it. And that I'll pause at that point. And I will now pass over to Professor Peter Hammond. Thank you.
Thank you very much. I hope that, could someone just confirm that they can see the first slide? And you can hear me? No? Hello?
Yes, we can hear you and we can see your slides, Peter.
Oh,
so
sorry.
Please do go ahead. That's okay.
I thought I was in a vacuum for a second. Okay, this introductory slide is just to confirm that I'm speaking as a member of WASP, Windrush Against Sewage Pollution. I'm not an ecologist, a biologist, and I've not worked in the water industry, so I've been a mathematician for 50 years, and my background is in computational biology, imaging, genetics. And the reason I got involved in this issue about sewage getting into rivers and polluting them is that I live on the River Windrush. This is a picture of the Windrush in 2009. The River Windrush flows under the building I'm in because I live in a former mill that's been converted. And this is the river in 2017. And we'd noticed, the local people, that the river was deteriorating over time. And by 2017, really, it was this rather turbid looking, sad, desert-like river with a huge loss of biodiversity in the river. But how did I get involved with looking at the River Culm? Well, the activities of WASP was noticed by Joe Crowley, who you'll know from Countryfile and other things. And he invited us to take part in the river pollution scandal, which was shown last April on BBC TV. So they came with a camera crew and we explained to them what we do. And obviously a lot of that was filmed and some of you may have seen it. Now, I would focus for that program on my area, which was based around rivers in West Oxfordshire and the Cotswolds. And it was actually Joe Crowley who picked the River Culm. He is a fisherman, and he obviously knows the Culm, and he decided to look at 4 of the sewage works off Culm, Willand, Culmpton and Bradninge in your area, obviously discharging treated effluent and other things into the River Culm. But before I explain how I go about looking for unpermitted or illegal discharges into rivers, I thought I should just very quickly show a simple explanation of what happens at the sewage treatment works. What is permitted? What kind of discharges are permitted? So here's my very simple model. We flush things down our toilets, we use showers, we use washing machines, etc. And obviously the network sewage pipes take that wastewater, plus runoff from roads and other things to the sewage treatment works, where very often it goes into something called a bouncing tank, which fills, and at some point it is filled enough for it to be pumped across to the treatment part of the sewage works. I'm not going to go into any detail on what happens, but 8 or 9 hours typically later, that treated sewage comes out as the effluent into the watercourse nearby. Sometimes not nearby, sometimes actually pumped quite a few kilometers to actually get to the river. So that's permitted treated effluent. Now, if the weather turns rather nasty and the excess runoff from the roads, etc., and groundwater getting into leaky cracks in the sewerage pipes starts to put the sewage works under pressure, it's permitted to actually divert an excess or carry on treating a certain amount of the sewage, but the excess can be diverted to a storm tank with a view, when the storm abates, to actually pump that back in and be treated. Of course, sometimes that tank will not be sufficient to cope, and the Environment Agency gives water companies permission to actually empty the storm tank into the same watercourse. Now, this is untreated sewage. It may be screened, but it hasn't gone through the treatment process. It'll be screened for, say, for solid objects. And with permissions to do things, typically you have obligations, and the water company would be obliged, for instance, now to have a monitor recording when these discharges happen from the storm tank or some other process that similarly discharges untreated sewage. And that records the start and stop times of those discharges. And the Environment Agency obviously monitors the quality of the effluent and specifies standards for that. It requires information about how much sewage is being treated, how much sewage is going to the treatment process, or possibly how much is actually being treated and coming out as effluent. And it also requires those records of the spilling times to be sent to them once a year. And in fact, as you might know, that's just happened recently, and then 21 days has just been announced by the Environment Agency on their website, and it's now gone into the Rivers Trust map. Now, in the permit, which is now electronic, but obviously could be a paper document, there are conditions on those sewage fills. The main 2 conditions that you might want to know about, that I'm particularly interested in, is that the spill should be caused by rainfall and or snowmelt. That's what it says in the permit. And also, if you are spilling, you must carry on treating sewage to the capacity of the sewage works. So as the pressure on the sewage rate rises, there's a point, a threshold, when, as I say, there can be some diversion to a storm tank, but you must keep on treating to a certain level. So the 2 major ways that unpermitted sewage spills can be made is that there's no rain. It could be that groundwater, even though there's no rain, there's groundwater still getting into the pipes, but the Environment Agency says that this is not an adequate excuse and is unpermitted. So that would still be illegal, even if there's groundwater getting in through the leaky pipes. Or it could be that you fail to carry on treating to the capacity of the sewage works, but you're spilling. Or you may have started spilling at the correct level, but then you let the treatment level go down. So we call the spill when there's no rain, a dry spill, a spill that doesn't carry on treated to capacity, an early spill. And so I have spent a lot of time looking at sewage works and trying to understand what's going on and when these unpermitted spills happen. To do that, you need to generate a lot of data, and that data is typically requested from the water company. And any of you could do this. You send an email and you say that under the Environment Information Regulations, you want to make a request for data. So for instance, you may ask for the spill data, which will give you a long list of start and stop times of the spills. You may ask for flow data, and that will tell you, for example, here, what's being treated in liters per second on average every 15 minutes. And if you combine those two together, you can look for occasions when those spills happen when the treatment is not at the capacity of the works. In other words, you could look for failures to, like early spills. That data comes from the water companies. You can get from public sources rainfall data, and if you combine that with the spill data, you can then look for dry spills. You can see whether the spillings occurred when actually there's been no rain for a series of days, or at the day of the actual spill, etc. And then you put it together. Now, I don't need to go into the detail of these charts, but this is, for example, 2 months of data for Culm. The pale blue curve is the sewage flow every 15 minutes for February 2020, the upper picture, and then for March below. The black horizontals are the spills via the storm tank to the River Culm, and the green is the rainfall. And so I've labeled some of these with an E, meaning they're early spills, because, for example, 9, 10, and 11 of February, what was coming out of the works was at 30% of the level of the minimum flow to full treatment. Now, I'll explain the difference in the questions about that. And that also explains, perhaps, to those of you who know why I haven't labeled every spill, that could possibly be an early spill as such. Down here on the bottom right, you can see I've also labeled some of the spills here with a D because they're occurring when there's no rain. And so those 3 spills there are both early and dry. That's just some examples for Culm. So what we did was we looked at the flow data that Joe Crowley had been sent by Southwest Water, and we found what we thought were 129 illegal or unpermitted spills to the Culm, divided across the 4 works like this. I also put the population in just to remind you of the relative size of the different sewage works. This was over a period of about 4 years data, but the most reliable is 2020. And again, I won't explain that right now, but 2020 found something like 100 of that 129 illegal spills. The data from the previous 2 years is less reliable, so I won't focus on that. What you notice I've also put in is not just the number of illegal spills, dry or early, but I've put the hours of spilling in, which is what the agency has recently published and is on the Rivers Trust sewage spill map, which you heard mentioned earlier. For 2021, the latest data, we don't have the actual detailed spill starts and stop times, but we do have the hours of spilling. And what you notice is that the number of hours has gone down at each of the works, and in some cases quite considerably. But I can't tell you exactly what's happened in terms of any illegal unpermitted spilling, because as I say, I don't have the data. But I do have it for a works not so far from you. So for example, down on the River at Ivy Bridge, I can tell you that over the same 4 years, the number of hours of spilling has varied quite a lot. 3,000, really quite a significant number in 2018, down to about 2019, up a little, and then significantly down this year. However, if you look at the number of illegal spills, in this case dry spills, the percentage relative to the number of actual spills has gone up. So it was 9% in 2020, but that's now gone up to 14% in 2021. So although the hours have gone down, the actual illegal spills have gone up. included these two charts here for Ivy Bridge because I just wanted to emphasize something else. So in addition to the flow, the pale blue line, and the rainfall in green, I've added another line, which is the level of the River Culm in centimeters on the left-hand axis. And I wanted to illustrate here that although some water companies say that these spills occur in a very swollen river, you can see from here that, for example, in very dry weather, when there's no rain down here in March, the river level's about 30 centimeters. But if up in February, it was spilling in the second week of February, when the river really wasn't very much above its dry weather level. So that was not a swollen river. I think another view that is interesting is to actually see, not look at sewage works in isolation, but think of them on the river and look at simultaneous spilling. So for example, in 2020, in January and February, Bradninch really spilled almost continuously for 3 months, and the others were spilling off and on. Then there was a gap over the summer with a little bit of spilling in June. And then the spilling started again in October. In fact, what we noticed, and some of you may know, of course, is that there is a spilling season which typically starts in October and goes on for about 6 months, getting quieter in April and May, etc.
Sorry to interrupt, Peter. You've got a couple of minutes now.
Okay.
Yeah, thanks.
I wanted to emphasize Willand. Willand has actually 2 ways of spilling, from a storm tank, also from an overflow at its inlet. I won't go into the details, but when those 2 overflows are spilling simultaneously, we can estimate the volume of what's going into the river at the inlet. Remember, this is untreated sewage, except in the case of storm tank overflow, it will be screened and settled to some extent in the tanks as solids settle to the bottom. Here it's just screened. And I estimate that 14 million litres of untreated sewage during those common periods when they both were actually spilling went into the river. That's the equivalent of about 5.6 Olympic-sized swimming pools. Now, the agency aren't on, so I don't think we can let them off the hook. I think we need to say something about that they've made a contribution to, I think, to the failure of regulation. 2 things relating back to the permit. The permits say that the spill must be due to rainfall or snowmelt. There is no description of how much rainfall. There's no threshold. There's no period of, say, heavy rainfall in 3 hours or something. And this is very easily, I think, exploited by water companies. And you'll find people complaining their local works is spilling when there's just 2 or 3 millimeters of rain in their locality. And then the second condition says that you've got to keep on treating even when you're spilling. That's what it says in the permit. But actually, what they forgot to put in the permit was to say, oh, by the way, you need to measure it. So lots of water companies measure what's coming out the back end, the so-called treated effluent. They don't actually measure what's going to be treated at the works. And so it's very difficult to check the compliance with that condition at many sewage treatment works. So just I wanted to say a couple of things about the broader spilling in rivers outside your area. In my area, in October last year, we published a report about 14 sewage works into different rivers, some of them chalk streams, and we identified more than 700 illegal spills into the river. This was 20 times more than the 33 that were actually on the Environment Agency's records. About a week later, the agency announced with Ofwat that they were going to have a major investigation into sewage. Many people believe this is because of the pressure from organisations like WASP and Salmon and Trout Conservation and Surfers Against Sewage. And indeed, Sir James Bevan admitted in a letter to a local MP that it wasn't just the threat of putting new monitors on sewage works, but it actually was the concerns raised by campaign groups and by WASP. Then in January this year, we published a larger report looking further afield, including the River Culm and your 4 sewage works locally, and that identified thousands of sewage spills into various rivers across the country. Now, I include this photograph. This is my garden. This is the river. Windrush flowing through the garden. You can see it doesn't look very healthy. And I wanted to point out that Ash Smith, who's the person on my right here, who founded WASP, is carrying not a walking stick, but actually a camera on an extendable lead, which he puts into rivers to make videos like I'm going to show you. So this is the Shield Brook. This is where the Carterton sewage treatment works, right next to Brize Norton Airport, the discharges into the river. And what you can see is that upstream of the sewage works, it's beautiful, clean gravel, some trout here. And then downstream, about a few hundred meters, it looks like this. So upstream, downstream. So the gravel's covered in silt. A lot of the plants are covered in silt and algae, and it's very turbid and opaque. But from the surface, you can't see a lot of that. So one of the things I'd like to encourage you to consider is actually getting some GoPro cameras if you haven't already got them and they're doing it, and actually capture some of these videos, and then combine those videos with your citizen science river quality data and the sort of data that I'm described to you about sewage treatment, about spills and rainfall, and get a much broader picture of the state of the river relative to the sewage works. And then you can decide with Southwest Cooperation to see whether those sewage works are having a particular micro effect in a locality of the river. And I'd also like to put a plea to Southwest Water, if they're happy to provide me with the spill data for 2020 and 2021 for all of their sewage treatment works, at no cost, I will offer to analyze that data and work with them and with you to analyze further instances where maybe sewage works are not treating up to the capacity they should be, or are being affected by groundwater, as I'm sure is the case in some of their works. So I'm going to finish there, I hope in time.
Excellent. No, thanks very much, Peter. That was really clear, and I particularly like your diagram near the start. I think that was really helpful. So yeah, lots of food for thought. If people have comments on that presentation, please add it to the chat. And we're now moving over to a video from Dr. Holly Pearson, I think, by Dominic.
Hello, my name is Holly Pearson and I work for the Westcountry Rivers Trust within the monitoring team. I'm really sorry I couldn't join you this afternoon, but I am hopeful that this recording will provide you with a good look at some of the monitoring that both we and the Culm CSI volunteers have been doing. So how do we know if our rivers are in good health? Well, accessing historical monitoring data and being able to compare that with current data is really key to answering this. And a look at historical river monitoring in the West Country by the Environment Agency over the last 20 years or so shows a clear decline in the amount of monitoring being undertaken. That's routine monitoring looking at river samples. And this graph shows the number of test results for the most common determinants for the year 2000 and then 2013 to 2020, and that's for temperature, conductivity, turbidity, suspended solids and orthophosphate, nutrients. And you can clearly see here, in some cases, the number of samples taken decreasing by up to 90%. And a similar pattern can be seen with the unique sampling sites from which samples are taken across the West Country. And dividing one by the other gives you an average number of samples taken per site per year. And the story for the Culm specifically is extremely similar, with the total number of samples taken dramatically decreasing over the last 20 years, as you can see from this graph. Now, I haven't generated the visuals for the number of unique sites for the Culm, but I can tell you that the number of sites monitored by the EA here has dropped from around 15 in 2000 to 1 in 2021. And so within the Connecting the Culm project, we've taken up the water quality monitoring using both a water quality sonde, which is a piece of kit that you can leave in the water and program it to take measurements as frequently as you want, and CSI volunteers. But what are we actually measuring? Well, we've been measuring a number of parameters. Some of those are measured by our sonde and some by the Culm volunteers. So we have electrical conductivity, And this is basically a measure of the concentration of dissolved ions in solution, which are capable of conducting an electrical current. Now, a river's natural background conductivity is governed by geology and soil type, and so knowing a river's normal baseline conductivity is important if you want to use this parameter as an indicator of pollution. Now, because this measurement doesn't tell you specifically what the pollution is, it can be indicative of things like slurry, silage, liquors or salts entering the watercourse. Now, there's no definitive threshold for conductivity since it's used as a proxy, but we set the Culm threshold at around 1.5 times the mean conductivity, which is about 430 microsiemens. And then dissolved oxygen, well, this is as vital for aquatic life as it is for those on land. And the amount of oxygen able to dissolve in water will increase with decreasing temperatures. And so climate change and warming waters are a real issue. Dips in dissolved oxygen will also follow organic pollution events, where increased microbial activity in the decomposition process uses up available oxygen in the water. And then we have turbidity, and we use this as a proxy for sediment, which is lost off the land via things like poaching of the fields and gateways by livestock, track erosion, and sediment from the riverbanks. Eroded riverbanks can even contribute to a river's turbidity. Now, sediment's a problem because not only can it act as a vector for other contaminants like pesticides and bacteria, but it can also smother the riverbed, which makes it very difficult for fish eggs to develop healthily. Again, there's no official threshold for turbidity, but we consider measurements above about 40 NTU to be high in the Culm. Temperature. I've already mentioned the relationship between temperature and dissolved oxygen, but temperature is also very important in governing fish migration, spawning times, and the successful development of embryos. And temperatures higher than about 18 degrees Celsius begin to cause some distress to the sensitive salmonid species like salmon and trout. Then we've got pH, and this is basically a measure of the acidity of the water. And this is very important in governing how different constituents in the water behave. And so this means that pH can affect the bioavailability, or the toxicity, if you like, of things like metals and ammonia to fish and other aquatic life. So an ideal river pH is somewhere between about 6.5 and 9. Then we have nutrients, and in rivers we measure phosphate, as this is considered the growth limiting nutrient here. And nutrients are present in things like fertilisers that are applied to crops to promote their healthy growth. However, they do become problematic in the watercourse when they sort of start to promote this algal growth. And this prevents light penetration and can lead to eutrophication, so using up of dissolved oxygen within the water. And for the Culm, the threshold set by the Water Framework Directive is sort of site-specific, if you like. So for the Culm, to reach good status for phosphate, you need to be less than around 0.18 milligrams per litre. And then we have our additional sort of contextual data, if you like, that our CSI volunteers are collecting with each of their surveys. And this includes things like identifying pollution sources, as well as wildlife sightings and issues with problem plants. So if we're trying to plug the monitoring gaps here and help support what little government body monitoring remains, we can maximise the effectiveness of these efforts by being a bit more strategic about our monitoring approach. Now, this is often easier said than done, but it's where having both a sonde deployed in the river and the kind of boots on the ground, if you like, with volunteers is so critical. Now, in an ideal world, we'd have a perfect setup whereby we'd have a magical sensor deployed at various locations along the main river and every tributary of that river, and it would give you instant, highly accurate, definitive data on the health of every part of that river. And you could sit back and relax, and that system would detect any problems and tell you how to go and tackle them. And all this information would be based on multiple frequent measurements made day and night, and would just alert you when you needed to know something. And of course, this just doesn't exist in reality. We've no magical sensors that you can do this with. We're always limited by the existing technology and the accuracy of that technology, its cost, the operational expertise needed to run these things. And that all impacts on the kind of spatial and temporal resolution of the data that you can gather. That is how often you can take a sample and how geographically spread out along a river those samples are coming from. And this leads nicely into the two kinds of monitoring that WRT and our Culm CSI volunteers have been busy undertaking and how they complement one another. So our Culm sonde is comparatively much more accurate than the kit supplied to volunteers, but for this you sacrifice cost, it's very expensive, and where it wins on temporal resolution, it lacks on the spatial resolution because it's so costly, you can't afford to put them in at multiple sites. So since one expensive sensor deployed near the bottom of a catchment is great at accurately highlighting the general response of a catchment to rainfall events and alerting you immediately when a river might be over or under a certain threshold, and it will collect a great number of data points for looking at changes in baseline water quality, it isn't able to tell you much about where the pollution is coming from specifically, or giving any contextual observational data with its measurements. Now the CSI kit, on the other hand, like I said, might fall a bit short on accuracy and the temporal resolution, but it offers up the merits that the sonde cannot in terms of its spatial resolution. So therefore, when you start to look at how all this works on a map, you can quickly see how these gaps in monitoring can be bridged very effectively using these two methods. So here's a sneaky peek at the 2021 Csi Scorecard for the Lower Culm, which will be ready for release very soon. Now, the Lower Culm score dropped slightly for this year compared to the year before, which was 57% overall, or a grade C, and for 2021 it's 55%. And the data really highlights those suspended sediment as being the biggest issue in the catchment, and the reasons for that being collapsed riverbanks, livestock access and soil runoff being identified by our volunteers. And phosphate and local ecology also score quite poorly, and this is largely due to slurry and silage runoff and the presence of invasive plant species such as Himalayan balsam and Japanese knotweed. Now, looking at the map again, these results can be mapped to start to build a picture of whereabouts in the catchment there are more issues with water quality. And you can clearly see here that the Lower Culm performs more poorly than its surrounding catchments. But there are still gaps to fill in terms of the Weaver, Ken, Fulford and Holberton catchments. However, great improvements have been made from 2020 to 2021, as you can see from the table below, where we have really had significant increases in recruitment, surveys and sampling points across this catchment, which is really great news. And so, by comparison, the increased temporal data resolution from the sonde allows us to clearly see how the catchment responds to rainfall, or if something occurs that's not related to rainfall at all. Now, the sonde was installed in July 2021, and the 6 months worth of data collected are shown here, and some interesting trends have been highlighted. Currently the data is automatically uploaded to a website called HydroView every 3 hours, where it can be viewed remotely in near real time, and the volunteers have access to this data set. So in this graphic we have tried to highlight some of the more interesting events, and some of which correspond with named storms like Storm Aurora and Storm Barra. And you can clearly see patterns in the data, such as increasing runoff causing these spikes in turbidity during rainfall, which here is shown by increasing depth. And this really supports what was found by the CSI community, where it really indicates that runoff from the land during these high rainfall events. Now, there's also some very low dissolved oxygen concentrations that we viewed during the summer of 2021. And you can see in these two graphs here of dissolved oxygen and temperature at the bottom that this kind of inverse relationship between the two, and how the prolonged periods of very warm weather can potentially drive oxygen levels down below that 5 milligram per litre threshold. Now, we saw in the summer of 2021 milligram per litre of dissolved oxygen getting below 6. So we had 67 measurements of it getting below the 6 milligram per litre mark, where we set a kind of conservative alarm, if you like. But you can really see how how climate change and warmer weather for longer periods could really drive this problem. And when it comes to conductivity, you can see these classic kind of dilution of the dissolved ions in the water, shown by that dipping in conductivity with rainfall. But there are instances in the data as well where there are increases in conductivity totally unrelated to rainfall. So this means we can also identify events that are not specifically related to runoff. Finally, we're working to try and make the Culm sonde data a bit more accessible and more engaging to our volunteers and other interested members of the community by automating some summaries of all this data. So as I said, the sonde is generating so much data, it's very difficult to be able to manually analyse that all the time. And also the way it's displayed in HydroView, it can be a bit daunting if you're not familiar with these kinds of plots. It can take a lot of effort, a lot of time to try and get your head around what the data is actually telling you. And so we want to provide more information on what water quality parameters indicate, highlight some of the interesting events for you, provide those contextual thresholds so you can really visually see when the data is kind of exceeding or coming below those thresholds, annotate the plots, and just altogether make that data more interactive. Currently, we have to manually annotate the graphs and rearrange the data for presenting this to the public. It's very time consuming, and this time lag can kind of demotivate those who would otherwise really be inspired by this data and be remotivated by having the data on a more regular basis. So our hope is that sort of understanding and motivation will increase if we can make data more engaging and immediately available. And so we have some ideas for how we'd like to do this. And we'd like to present these to you CSI volunteers and anyone else who's interested in a dedicated workshop so we can incorporate your wants and desires into the final output. So we can kind of make suggestions, but it's really feedback from you that will be really important in making this as usable as it can be. So we'll be sending out information on this in due course. So thank you very much for listening, and please do contact me or one of my colleagues, Lydia or Simon, with your monitoring or CSI related questions. Thank you.
Oh, fantastic. Well, there's a lot to take in there. Hope you followed it. We are going to test you at the end, by the way, only joking. And yeah, moving swiftly on because of time, on to I'd like to invite Richard Horrocks, who's a Riverfly coordinator in the Culm, to say a few words. Thanks.
Okay, can you hear me?
Yes.
Good. Right, well, unlike the other speakers, I'm not an expert, and I would best describe myself as an informed amateur. But I am someone who lives in the catchment and wants the Culm to be a healthy river. My principal involvement has come through interest in fishing. And I fished the Culm for trout since the 1980s and have chaired the Culm Fly Fishing Club for the last 20 years. And our principal interest is between Hemiock and Culmstock, although we do have members who fish the river elsewhere, so know it along its length. What I'm going to do is just run through some events over the last few years, which describe, as that informed amateur, what we've been trying to do to improve the quality of the river. Now, in 2011, the Riverfly initiative was launched, and we started surveys on the river in that year. The surveys measure diversity and quantity of river invertebrates and therefore gives an indication of the health of the river. We have 13 sites on the river. 10 of them are on the main river, from above Hemiock down to Rue, and we have 3 on the tributaries. And in general, we have good scores above Hemiock. That's scores of 16 or above in Riverfly terms, and that is as good as almost anywhere within the whole catchment. But it halves as you progress downstream. Reduction as you go downstream is not unusual, but it is a cause for concern, and there are reasons for it. because of our concern, a case was made by the River Ex and Tributaries Association and the Westcountry Rivers Trust to the Environment Agency to make the river a case for special attention to address the poor state of the river. We know that the river was in a poor state from the fact that the numbers of sites where trout were declining or absent was increasing. And the Water Framework Directive classifications showed that 30% of the catchment had worsened between 2009 and 2016, as has been mentioned previously with the evidence review. Unfortunately, although the case was made, it wasn't received and the baton wasn't carried on by the Environment Agency. They heard what we said, but weren't prepared to do anything in particular. Moving up to more recent times, in 2021, of course, we have the Connecting the Culm project, and the evidence was collected together and workshops were held to discuss it in February and March of last year. And the evidence presented was that 75 to 90% of the phosphate load in the River Culm is from agriculture. And the general impression was given that this appears to be getting worse for the agricultural pollution, whilst the sewage related pollution was getting better. And there was no mention from either South West Water or the Environment Agency of unpermitted spills. Later in the year, we started the Csi surveys. They actually started in 2020, but 2021 was the first full year. And a number of Riverfly volunteers agreed to carry out the CSI water quality surveys alongside the Riverfly surveys. And this applied to 9 sites on the river, 6 on the main river and 3 on the tributaries. And of course, many other CSI surveys were also undertaken by the public, as shown on the previous presentation, and entered onto the database. But I can only speak for the ones where I've seen the actual results that we collected. And in general, phosphate levels above hemioc were less than 100 parts per billion. And below hemioc, they increased from around 100 to 300 parts per billion. Phosphate is the only chemical, if you like, that we measure as part of the CSI, so I can't comment on anything else that might be there. The worst site consistently in the Culm catchment was on the Stratford stream at Culm, and we were getting readings there as high as 680 parts per billion. The Culm itself was in that range 100 to 300. However, there was an event in September 2021 when I was undertaking the Riverfly survey at Whitehall, which is roughly halfway between Culmstock and Hemioc, and I was surprised to find a reading of 770 parts per billion. Conditions were not unusual. It was a typical month, dryish, but not unusual for September. And this level was far higher than anything I previously measured. And so I went up to Hemioc Bridge, Millhays Bridge, which isn't a regular site, but it was the first easy point of access above Whitehall. And I took readings there. And the reading there was only 90 parts per billion compared with the 770. And the only significant inputs between those sites were the Brook, which is generally quite a high quality stream, which has recorded quite good trout numbers in the past, and the Hemioc sewage treatment works. However, apart from recording that, thought no more about it. At the same time as the surveys, we have notes on the surveys, and volunteers were reporting that we've been getting fewer trout below Uffculm, certainly seeing fewer trout, and these are experienced anglers who recognise and look for rising trout. So that brings us up to the present time, the late 2021, early this year, when the reports came out about the sewage spills in the river from the River Trust and from WAS, and which alarmed us because we saw the Culm to be one of the worst 10 rivers in England that were studied. We've always accepted expert opinion in good faith, but we're now left wondering what's going on. Can we trust what we're being told? How can we trust that? And does the situation need revisiting and further review? Whatever the issues are, I want whatever it takes to happen to prevent the Culm ending up like the Windrush and other rivers. That's pretty well my sort of case summarised. Thank you.
Excellent. Thanks very much, Richard. There's some really powerful points in there, very clear, and yeah, we look forward to talking about them at the end in the Q&A. So now, yeah, could I pass over to Ross Cherrington, please? Apologies, we are running a bit behind time. Ross is going to talk to us about impact of farming on the river. Thanks.
Just an introduction. So my name is Ross Cherrington. I'm the Senior Farm Advisor for the Westcountry Rivers Trust. I don't actually work in the Culm, but what's happened is I happened to mention to Duncan that I knew that the connection to the Culm was going on. We had a farm advisor working on the river. Is that they actually, funny enough, the Environment Agency are now taking an active interest in the farms on the river. So the Environment Agency are now inspecting farms within the River Culm based on what's known as the Farming Rules for Water, which were brought in with very little fanfare in 2008, essentially to reduce the amount of nutrients from manures and fertilizer and soil getting into surface water. Up until last autumn, there was very little in the way of inspections, and there certainly hasn't been any enforcement. No farmers have been prosecuted under the Farming Rules for Water so far. It is very much an advice-led progress, and it was especially brought in after initial experiences in the River Axe catchment, just a little bit further east, which showed that farmers, at least 5% of farms in the River Axe catchment, were not meeting minimum standards for their storage of slurries and silage and manures. And a fairly robust inspection and work package in the River Axe has managed to get those farms down to nearly 40% not meeting minimum standards so far. There are lots of rules, as you'd expect, but actually Farming Rules for Water are quite simple. It's all about planning your manures, and it's all about having, as I say, that minimum standards and amounts of slurry and silage storage. So for slurry, the minimum amount farmers should have is for 4 months, excuse me, and for silage, those silage clamps should be built to minimum standards. There is, unfortunately, a get out of jail free card, which is the pre-1991 exemption, as long as the structure is not polluting. And if you haven't built a new slurry pit since 1991, and you haven't got performance storage, you're not but the inspectors are now in the Culm, and they're going in there and they're finding about 95% failure rates for Farming Rules for Water. And where they're finding that, they're now making farmers at least plan to work out how they're going to get that 4-month storage for future slurry stores. And in the best will in the world, if you haven't got 4-month storage, preferably 5, you're going to have to spread slurries when things are inopportune, and your phosphates and your nitrates will then end up heading towards the river. And this happens in every river as well as the River Culm. But the big thing now is that as farmers don't plan to use their organic materials and they just get rid of it because they have to, that is a breach of the Farming talked about that. Okay. And there's just a photo of a slurry pit. And you can have an old earth bank slurry pit. That's not a problem. It's when you start building a new one, you then have to hit minimum standards. And there are lots of rules. So no spreading when it's covered in snow. And if you're, if it's too wet to drive on the fields and you're spraying it over the hedge, then that is the field is waterlogged. You can't spread the slurry there either. These things are all parts of good practice. They've been around for ages. Nothing's great change. It's just the environment age now go in and wave a bit more of a stick than they have done beforehand.
Ross, sorry to interrupt. We're really struggling to hear you clearly.
Very sorry. Shall I say
it...
that it's just my computer, and shall I let you get on, and then you can pass my presentation on to those who need it?
Yeah, I mean, there's a huge amount of information we've already got from you. It's all really very helpful. I mean, is there a summary slide that you could talk us through?
No, I think the best thing is I'll send you the slide, Duncan, and then we can you can use it as you want to. I'm very sorry about that.
No need to apologise, and we have absolutely got the gist of what you've been saying. It is really tricky to hear.
Okay.
So yeah, maybe if you could pick up, there's probably going to be quite a lot of comments in the chat, so
okay,
you could pick up on those. So yeah, thank you very much.
I'm very sorry about that. That's
okay.
That's just me being a Luddite.
No problem.
It's not, Ross, don't worry. It's an issue with our laptops. Don't worry. It's not you at all.
Okay, thank you.
But thanks very much indeed for persevering.
All right.
Yeah, thanks very much. So yeah, on to Mark Worsfold now, who is from Southwest Water, is Director for Asset Management. So Mark is on the line and wanted to share a presentation.
Wonderful. We're up and running. Thank you. Huge thanks first to Tim for inviting us along and the invitation to speak today. For those of you who don't know me, my name is Mark Worsfold. I'm Director of Asset Management here at Southwest Water. I've been in the water industry for over 30 years. I'm a chartered engineer, and I've previously been with another water company. I've been with Ofwat, the economic regulator, and I've been down here at Southwest Water for the last 7 years. So I've had quite a lot of extensive experience in the industry and around many of the issues that we're discussing today. What I'm going to talk to you about today particularly is our Water Fit initiative that we have literally launched about a week and a half ago. And that is about how we make significant improvements in terms of river water quality and bathing water quality over the next 3 years up to 2025. So moving on a little bit about Southwest Water first, we serve over 2 million customers, and on top of that, there are also 10 million people visiting the Southwest who use our facilities over each year. We have about 19,000 kilometres of sewer pipe across the region, and that's enough to kind of reach Australia and back. Well, it's just Australia, it's not back. And we are putting in place a significant programme. We're on track to deliver our improvement programmes that were already in the plan, but we're now looking at injecting quite an additional sum in order to achieve these additional benefits, which we'll talk about. There are around 2,500 employees within Southwest Water, and we have also got other commitments around net zero by 2030, where we're investing in renewables across the Southwest. So there we are. What are these things I'm talking about in Water Fit? So we have launched 6 pledges, and I'm going to take you through each of these in a little more detail so that you can see what's involved. The first of these is nurturing healthy rivers and seas, and this is probably the biggest commitment, where we're looking to reduce our impact on rivers by about 1/3 in the next 3 years. And then the second is putting nature on everybody's doorstep, creating and restoring habitats, inspiring local champions. And I was really pleased to see some of the things that Holly had in there around CSI and the citizen science, because that's exactly what we want to inspire as well within our work. Creating a sustainable future, and then putting people in control. And in particular there, it's about that transparency of data and information. So let's just quickly chat through these 6 pledges and talk about, so how will these be measured? What are we talking about? And what is actually involved in that? First is to reduce our impact on rivers by 2025 by 1/3 and put forward plans to target 0 harm by 2030. So a lot of that is around reducing spills from our storm overflows to an average of 20 per year by 2025. And at the moment, in the data that was published at the end of March, which all of the water companies have put forward to the Environment Agency have published, and each of the water companies have published on their websites as well. We currently have around 37 spills per EDM each year. And so we set ourselves quite a tough, ambitious target to get down to 20 by 2025. It's about maintaining our excellent bathing water standards, and we're achieving 100% bathing water standards this year. And we're going to try and maintain those all year round so that everybody can enjoy our 860 miles of coastline, and then deliver 0 serious pollutions by 2025, and a target for year-on-year reduction in all pollutions. We also want to put nature on everybody's doorstep. So there's a commitment in there around making a bathing water accessible in less than an hour's drive for 100% of our residents and visitors, and provide access to our 40 inland lakes and reservoirs so that local communities can continue enjoying them for health and recreation. And in particular, we have a bathing river quality pilot, which is actually occurring on the Dart and Tavy. And within that, we are looking to put in place bathing water pilots. And actually, there should be bathing water classifications that come from that on the rivers. And those are the first within the Southwest region. That pilot is currently underway. It involves a lot of river monitoring, as Holly was talking through. And it's all there about trying to understand what needs to be put in place, what improvements do we need to put in place, and how do you monitor and demonstrate river water quality for those catchments. We've found 8 potential bathing water sites within the Dart and Tavy catchment, and we're now evaluating those for which ones we would actually go forward with. Next is creating and restoring habitats. And we have 120,000 hectares of regional farming land that we're engaged with, and we do a lot of work with Westcountry Rivers Trust on that. And we want to stop pollutants from that farmland going off into rivers and seas by 2025, and we're going to be working with local partners to achieve that. We're also restoring about 1,000 hectares of peatland by 2025, again to improve the habitats in those areas, and also do things such as carbon sequestration in those areas. We're planting 250,000 trees by 2025. Again, that's to reduce runoff, and that runoff will improve river water quality. And that will be quite key, both from a carbon perspective and also for reducing runoff. Next, we're inspiring local champions, and we've got a community fund set up, and we're looking to demonstrate and donate 25% of that community fund to those local groups that share a passion for river and sea health. And that is where we certainly want to engage around the citizen science arena. We are launching our Water Fit Warriors program, and then we'll be sharing progress with our customers through what we have as a unique scheme, which is the Water Share Plus, whereby customers actually become shareholders. And at the minute, 1 in 16 of our customers is actually a shareholder now in South West Water. And so they have the right to hold us to account. They have the right to challenge us about what we're delivering. And similarly, they are part of the share ownership of the Southwest. Next, we're creating a sustainable future, and here's where we want to work collaboratively with others across the region, and particularly around things like non-flushables, plastic containing wet wipes, which create and generate blockages. We have over 8,000 blockages a year here in the southwest, and many of those are driven through wet wipes. There's a lot happening in that space at the minute in order to reduce fatbergs and reduce blockages. Particularly, Fleur Anderson, the MP, is taking that through Parliament as a private member's bill in order to ban wet wipes. And we're also seeing quite a lot of work around an industry fine to flush standard, where now over 100 products in supermarkets are now plastic free. And those are now being promoted and produced. Tesco's, for instance, have banned the use of all plastic wet wipes now on their shelves, and Boots are following suit with that by the end of this year as well. So quite a lot happening in that space, and it's certainly something where we need to engage with all our customers, but not just our customers, our 10 million visitors who come to the region every year, because we find that the visitors actually behave differently when they're on holiday than they would do if they were in their own home. And that's something where we need to encourage them, because what we don't want is, we want them to come to the region, we want them to enjoy the region, but what we don't want them to do is impact upon the region in doing so. Finally, putting people in control. And I think this is a really important area about data transparency and information. There is a lot in the current Environment Act where we are seeing both improvements in terms of storm overflow visibility within an hour, and also river water quality monitoring. And alongside that is an improvement in data transparency and visibility, so that that information is directly available from websites, and people can use that data to make informed decisions, whilst also participating in a citizen science space. So that's certainly something we're looking at piloting quite a lot within the Dart and Tavy catchments, and we'll be working with many stakeholders through that pilot about how that real-time sharing of information and data can be best achieved, so that when we're looking at rolling that out across the whole region, that actually it's meaningful, it's practical, and people can see and understand that data. And I think that's a point Holly picked up on in her presentation, that there's a lot of time and effort needed to take data to information, and therefore it be something meaningful that the end users can use. Moving on then, there's been quite a chat about storm overflows, and I've got a little diagram here that shows what a storm overflow is. Fundamentally, a storm overflow is a relief valve that is there so that in times of heavy rain, that actually it's there to provide relief and not see sewer flooding occur into people's homes. We've done quite a lot of engagement with customers and research around this. And what we're finding is that customers don't want to see storm overflows removed completely. What they want to see is the frequency of operation removed and reduced over time. And so that's actually what our WaterFit program is focusing on, is actually how do we reduce the frequency of storm overflow operation at both storm overflows and combined sewer overflows, at pumping stations, at treatment works, and what do we need to do to make that and change that position so that performance improves. And so we are now investing over £330 million over this period, and that compares with, we've spent over £9 billion since privatisation in 1990, and have improved the performance of our sewage treatment works, and the impact on rivers has reduced dramatically over that period. But we're not complacent. We know we've got more to do, and that's why we're looking now at this programme to drive it forward, and look at what we need to do. And that is facing all sorts of challenges around population growth, tourism, wet wipes we've already touched on, but there's also the challenges of climate change and of what we as an industry call urban creep, which is where people are paving over both their back gardens, and we're seeing now quite a trend of people paving over their front gardens, and particularly for electric vehicles, because they want to get their vehicle close to their home so that they can charge it. And in the process, what we're seeing then is an increased impermeable area being put in place that then needs to be drained. So specifically for the Culm, I've talked a lot about what that programme involves. It actually involves us investing more than 1.3 million in the Culm catchment and doing quite a bit of work to improve storage capacity, pump performance, resilience, inlet screens, upgrading equipment within the treatment works. And we're targeting to reduce storm overflow usage by approximately 75% in the Culm catchment by 2025. But we need to do this in partnership, and we need to do this working together. And you know, we will be continuing to do much of our work, things such as upstream thinking. And what I've showed there is just we're doing upstream thinking currently in the X catchment, and we're doing it in the Otter catchment. But we're not currently running an upstream thinking program in the Culm. Maybe that's something we need to talk about and put in place, because actually I think there's some really important things that we need to do in there. We're also consulting on our plans, not just for these 3 years, but for the next 50 across our drainage catchments. And we'll be publishing our drainage and wastewater management plans in June this year with a view to those are the draft plans. We want everybody's consultation and input into those plans, and those are due to be finalised by March 2023. So we really want your feedback and input to those when they're published. So ultimately, it's all about how we work together to deliver this. There's a lot of things we need to do. We know that we're not complacent. We know we need to take much more action and deliver a lot of things. We're talking on there about quite a number of other initiatives we've already got in place around upstream thinking, Love Your Loo and ThinkSync, in order to reduce those wet wipes and reduce things like fatbergs. Ultimately, we want to work together with everybody on this call about how we can achieve those goals. And as I said, we have set out some pretty stretching targets around, you know, reducing our spills by 1/3 by 2025. So that's me done. I'm going to finish there and we'll move into the questions.
Excellent. No, Mark, that was really helpful and very clear. The chat's been going crazy while you've been talking. I mean, I was just going to say a couple of things very quickly because I'm aware we're running out of time. The first is that we'll share all the questions in the chat, and I'm looking at Mark and others really, hoping that we could produce a Q&A so we can answer some of the detailed questions and get those back out to people, because obviously we're not going to have time to do all those technical answers now. And that the other quick thing I wanted to say was anybody who's keen to be on we're proposing a task group to look at these the issues in more detail. Perhaps I don't want to land Mark in it, but maybe Mark and others could act as a sounding board on that. So again, if you could put in the chat or email us at the hello email, if you'd be interested in being on this task group to just look into this issue on the back of this call in a whole load more detail. So there's sort of two immediate actions. And yeah, as I say, there's lots and lots of questions in the chat. I mean, if people are prepared to hang on just a few extra minutes, we could squeeze a few in. So I don't know if Dominic wanted to kick us off with a question. I've got a few jotted down as well. Or I could start off, Dominic, if you like.
Go ahead, Tim. I'm just digesting. I mean, it might be worth, okay, in the short time we've got, probably the most questions have come Mark's way.
There was a quick one from earlier, if I just jump in with that one, saying the best source of rainfall data, would it be the Met Office? I think that one was for Peter, if Peter's able to quickly answer that one.
Yeah, the Met Office is a possibility. There is a website called meteostat.net, which has some good rainfall data, and from a lot of different weather stations around the world, actually, it does a lot. And if it doesn't have data for a specific location, it can do some kind of, you know, fancy interpolation and give you some good information on your locality. Meteostat.net.
Brilliant. Thanks, Peter. I'll just pop the link to that in the chat so that people can follow that one up if they like. Thank you. Back to you, Tim. Or
I
do you
was
like-
just picking out a good question from Mark, which is when will you be releasing data on volumes of untreated discharges and not just duration of spills? That was a question from Jan Metcalf.
Okay. That's an interesting one, and it appeared quite a bit at the EAC as well, in terms of the various comments from a number of the MPs. I think one thing people quite need to understand is what an EDM monitor actually does. So an EDM monitor just measures the height above the weir, and actually, therefore, what we're saying is we can say when a storm overflow starts to discharge, and we can say when it ends to discharge because of the height it has above the weir. What that doesn't do is measure volume. So the EDMs that have been deployed, and there are over 16,000 EDMs across the industry as a whole. Sorry, 16,000 storm overflows. There's 12,000 that are currently monitored by EDMs. None of those are measuring volume. So if you were to say, when are we going to release volume data? We don't currently measure volume occurring at storm overflows, because actually there isn't a easy way to do that, and the instruments that have been deployed do not measure volume.
Can I just interject there? Mogden Sewage Treatment Works, managed by Thames Water, has a volume on its spill outfall, and it recorded in 2020 in October 1 billion litres spill on 2 days successively. That's 400 Olympic-sized swimming pools of untreated sewage going into the Thames on 2 successive days.
Yeah. So what you refer to there, Peter, is volume measurement at treatment works, not volume measurement at the whole of the storm overflow arena.
But that would be a start.
Yeah. Well, that's a interesting observation, Peter. Yep. We'll look at what does that mean, and I know there's quite a bit of industry work looking at that flow measurement as well.
Okay. Yeah, there's just to move on to another series of questions. So people are asking about how do we obtain or set baselines, and this is citizen science groups, and what can CSI, citizen science investigation volunteers do to help our farmers make changes? So in my mind, that would be one thing that this task group would look at. How can we best support the citizen scientists to go and gather the data? How can we support them linking up with the farming community, and how can we use specialists and experts like Mark and the Environment Agency and others to help people understand how baselines are set? So I think that would be another aspect of this proposed task group. Did you have another thread, Dominic or Sarah?
There was a brief one on why is there no legal level for dissolved oxygen and oxygen. I know that's from fairly far back, but I guess there's so many questions for Mark, it's hard to unpick them all. But if anybody can comment on why there's no legal level for DO, maybe Simon Browning, who I think is in the room, that would be brilliant.
So that there are Water Framework Directive standards for dissolved oxygen. The problem with oxygen levels is they vary wildly throughout the day, particularly in summer, with the natural trough being around sort of 4 in the morning due to sort of respiration and things. So never a time when the Environment Agency are likely to be out sampling. So traditionally, there's not been a lot of attention paid to using spot sampling to analyse for effective DO levels. What you saw with the sonde is that we can do that now to measure that whole range of dissolved oxygen levels. But I guess the standards are set around still maybe monitoring spot tests, and it's around what the 90th percentile should be. So it needs some work, but that's where the continuous sensors are absolutely perfect for dissolved oxygen, and we will be looking at driving a classification of river quality based on that continuous data. But it's never really been, it's not something that is likely to land anyone in prison or in fine, with a fine, simply because spot sampling is so bad at capturing it. what you will see is loads of dead fish as a result of dissolved oxygen, and that will, if picked up, land people in trouble.
Thanks, Simon. Any quick last question? Have you got one, Dominic, or should we move on to summing up?
There was a question from Jeffrey Bassett saying, how come the Culm at Culmstock has started to develop sewage fungus in the last 2 years if water quality is improving? That might be one of a key question for the task group, but I don't know if there's a quick comment from anybody on that.
Maybe need to unpick that in a smaller group.
Yes,
I guess. So, yeah, I mean, sadly, we're out of time and aware that there's a lot of unanswered questions here, which is why we absolutely wanted to suggest really that if there was sufficient appetite to set up this task group, what we'll do, I mean, obviously you've joined this evening. What we'll do is we'll contact you again. You don't have to sign on the dotted line now, but we'll invite you all to be part of this group. As I say, we'll get the questions answered and get those out to you. So in terms of next steps, got a few events coming up. So I don't know whether you want to pop this in the chat, Dominic or Sarah, but 4th of May, we've got Connecting the Culm working group meeting. And that's very fluid. So if you want to come along and rattle our cage and say we should be doing more for water quality, please do. 25th of May is the Connecting the Culm forum that we have every few months. 28th of May is a training session for citizen science investigators, or CSI, at Sanford Peveril, just in the catchment. And then to keep in touch with us, join up for our newsletter, or there's hello@connectingtheculm.com that Sarah's put in the chat a few times. So that's, just leaves me to say really that to thank the speakers very much for coming along. Thank you for coming. I think we've covered a lot of ground. There's an awful lot of chat, very useful chat that we'll get back out to you. Please keep in touch with us, join us, and it's a bit like a snowball, this project. It keeps on sort of getting bigger in a good way. So thanks for your support, and have a good evening. So thank you.